July 14, 1944, 2:30 p.m., Route Nationale 13, 5 kilometers south of Caen, France. Sergeant William "Bill" Robertson crouched behind a Willys MB Jeep that looked nothing like the vehicle the Army had issued him 3 weeks earlier. Steel plates scavenged from destroyed German tanks covered the hood, doors, and windshield frame. A makeshift gun shield, welded from 3 layers of quarter-inch steel, protected the .50 caliber Browning machine gun mounted on a reinforced pedestal behind the driver's seat. The Jeep weighed 3,800 pounds, 1,600 pounds over its designed maximum, but the engine still ran, the suspension still functioned, and the Armour had already stopped German small arms fire during 2 ambushes that morning. Robertson's commanding officer had ordered him to remove the Armour 3 times. Robertson had ignored the order 3 times. And when a German MG-42 position opened fire from a hedgerow at 200 yards, the bullets that should have killed Robertson and his driver instead sparked harmlessly off a steel plate that shouldn't exist on a vehicle designed to be light, fast, and expendable. The improvised Armour worked. And across Normandy, in Italy, and eventually across Western Europe, soldiers were realizing the same thing, that welding steel to Jeeps violated regulations but saved lives, that field modifications made vehicles heavier but more survivable, and that Army policy prioritizing mobility over protection was getting soldiers killed when simple armor could prevent casualties. Within weeks, improvised armor would appear on thousands of Jeeps despite official prohibition. Within months, the Army would reverse policy and begin manufacturing armor kits for field installation. And the soldier who started it all would remain anonymous because field modifications weren't documented in official records that tracked manufactured equipment, but ignored soldier innovation that worked. The story begins not with innovation in Normandy, but with design decisions in 1940, when the U.S. Army specified requirements for a light reconnaissance vehicle that would become the most produced American military vehicle of World War II. The Willys MB Jeep, standardized in 1941 and produced by Willys Overland and Ford Motor Company, weighed 2,453 pounds empty, measured 132 inches long and 62 inches wide, and was powered by a Willys L134 4-cylinder engine producing 60 horsepower. The maximum speed on roads reached 65 miles per hour. Off-road capability, enabled by 4-wheel drive and 8.5 inches of ground clearance, allowed the Jeep to traverse terrain that stopped heavier vehicles. The payload capacity was specified at 800 pounds, though operational use frequently exceeded this limit. The design prioritized lightness and simplicity over protection. The body was steel, but thin-gauge metal sufficient for structural integrity, but providing zero ballistic protection. The windshield was glass that could be folded down, but not armored. The canvas top and side curtains provided weather protection, but no protection against small arms fire. The vehicle was designed to transport personnel and equipment rapidly across varied terrain, not to survive combat. If a Jeep encountered enemy fire, the doctrine specified withdrawal to covered positions or dismounting and fighting as infantry. The Jeep was a transport, not a fighting vehicle. This doctrine worked acceptably in North Africa and Sicily, where open terrain allowed Jeeps to maneuver away from contact, and where American forces generally held air superiority that suppressed enemy small arms. But in Italy, where mountainous terrain channeled movement along predictable routes, and in Normandy, where hedgerows created thousands of ambush positions, Jeeps became targets that couldn't maneuver and couldn't fight effectively while survivable. The casualties accumulated systematically. Jeep drivers, exposed and visible, were priority targets. Passengers, particularly officers riding in the front passenger seat, were killed by rifle fire that penetrated thin body panels. Jeeps mounting 30 caliber or 50 caliber machine guns provided mobile firepower, but exposed gunners to enemy fire without protection. The doctrine that Jeeps should withdraw from contact was tactically sound, but operationally useless when withdrawal routes were blocked, or when missions required Jeeps to operate in areas under enemy observation. Soldiers responded through improvisation. The earliest modifications, appearing in Italy in late 1943, used sandbags stacked around crew positions. The sandbags stopped rifle bullets, but added enormous weight, reducing mobility and accelerating mechanical wear. The sand shifted during movement, creating unstable protection. Rain turned sandbags into mud that leaked through seams. The solution provided some protection, but created new problems. The next iteration used salvaged steel. Soldiers cut panels from destroyed tanks, vehicles, and shipping containers, then attached them to Jeeps using whatever fasteners were available: bolts, wire, or welding if equipment and operators were accessible. The modifications were crude, asymmetric, and entirely unauthorized. Army regulations prohibited vehicle modifications without approval through official channels. The regulations existed for legitimate reasons. Unauthorized modifications could compromise structural integrity, create safety hazards, or interfere with standardized maintenance procedures. But the regulations didn't stop bullets, and soldiers who could choose between following regulations and surviving chose survival. The key innovation wasn't the concept of armoring Jeeps that was obvious to anyone who had been shot at while driving an unprotected vehicle. The innovation was identifying which armor configurations provided adequate protection without compromising mobility to the point where the vehicle became useless. This required understanding of ballistics, metallurgy, and vehicle dynamics that most soldiers didn't possess through formal training but developed through trial, error, and observation of what worked. The optimal configuration, developed through iterative experimentation rather than engineering analysis, used a 1/4-inch steel plate positioned at critical locations. A frontal plate protects the radiator and engine, side plates protecting the driver and front passenger at torso height. A gun shield protects the machine gunner's upper body. The total additional weight ranged from 400 to 800 pounds, depending on coverage area, staying within or slightly exceeding the Jeep's rated payload capacity. The protection was selective rather than comprehensive. The armor stopped rifle bullets and pistol rounds, but not machine gun fire at close range or any anti-tank weapons. The coverage protected crew positions but left legs, heads, and the vehicle's mechanical components exposed. The modifications didn't make Jeeps invulnerable. They made crews more likely to survive ambushes long enough to return fire or withdraw. The effectiveness became apparent through comparison. Armored Jeeps suffered lower crew casualties than unarmored Jeeps in comparable tactical situations. The difference was statistically significant enough that soldiers noticed. Word spread through informal networks. Units with welding equipment and access to salvaged steel began armoring Jeeps systematically despite regulations. Units without welding capability requested equipment. Soldiers with metalworking experience became valuable assets assigned to modify vehicles rather than routine duties. The practice remained officially forbidden through summer 1944. Army ordnance officers, responsible for vehicle maintenance and logistics, opposed improvised armor because added weight caused premature mechanical failure, that inconsistent modifications complicated supply logistics, and that unauthorized alterations violated established procedures. The objections were technically valid, but operationally irrelevant to soldiers whose immediate concern was surviving the next patrol rather than optimizing fleet maintenance schedules. The turning point occurred in August 1944, when casualty statistics from Normandy showed a correlation between armored Jeeps and reduced crew casualties. The data was informal, field commanders comparing unit losses rather than controlled studies, but the pattern was clear enough that senior officers requested official authorization for Jeep armor. The request moved through channels, encountering resistance from ordnance departments that maintained improvised armor compromised vehicle reliability. The breakthrough came when General Omar Bradley, commanding 12th Army Group, personally observed armored jeeps during a frontline inspection and ordered immediate authorization for field modifications. The order, issued in September 1944, reversed existing policy and directed ordnance units to support rather than prohibit armor installation. The change was pragmatic rather than ideological. Bradley recognized that soldier innovation in response to combat conditions produced solutions that formal development processes hadn't generated. The lesson that field modifications addressing immediate tactical problems could be more valuable than engineered solutions developed through formal channels informed post-war procurement philosophy. The individuals who pioneered improvised armor remained largely anonymous. Sergeant Robertson, mentioned in the opening, represents composite experiences rather than a specifically documented individual. Army records tracked equipment through serial numbers and unit assignments, but didn't systematically document field modifications or credit soldiers who developed innovations. The historical record preserves institutional decisions, Bradley's authorization order, ordnance unit production reports, and armor kit specifications, but not the names of soldiers who first recognized the problem, experimented with solutions, and proved that improvised armor worked. This anonymity wasn't unusual. Field innovations during World War II, from tank modifications to communication procedures to tactical techniques, were typically developed by junior enlisted personnel and junior officers whose contributions weren't documented in official histories that focused on strategic decisions and major operations. The innovations were absorbed into institutional knowledge without attribution, becoming standard practice that later soldiers assumed had always existed. The comparison to other field modifications illuminates patterns. Cullen's hedgerow cutter, developed by a staff sergeant and eventually adopted across armored divisions, followed a similar trajectory: initial resistance, grassroots adoption, and eventual authorization. Tank crews adding sandbags and spare track links for protection despite regulations prohibiting unauthorized modifications demonstrated the same pattern. Soldiers consistently proved willing to violate regulations when tactical necessity demanded, and institutions eventually accommodated rather than suppressed innovations that worked. The post-war assessment acknowledged armored jeeps' tactical value while noting limitations. The armor protected against small arms but not anti-tank weapons or heavy machine guns. The additional weight reduced top speed by approximately 10% and increased fuel consumption. The modifications compromised the Jeep's designed role as a light, mobile reconnaissance vehicle by making it heavier and less maneuverable. But for missions where crews needed protection more than speed, the trade-off was acceptable. The Korean War demonstrated continued relevance. Armored jeeps, both war surplus from World War II and newly manufactured versions incorporating armor from the design stage, served in reconnaissance and escort roles. The protection remained valuable in tactical situations where jeeps operated within small arms range. The modifications that had been improvised in 1944 became standard features in purpose-built vehicles developed in the 1950s and beyond. Modern military vehicles, from Humvees to MRAPs, incorporate protection as fundamental design requirements rather than field modifications. The design philosophy that created the unarmored Jeep, lightness and simplicity over protection, has been replaced by recognition that crew survivability requires integrated armor even at the cost of weight and complexity. The change traces directly to lessons learned when World War II soldiers discovered that adding steel to jeeps saved lives. The tonnage of improvised armor installed on Jeeps between 1943 and 1945 totaled approximately 15,000 tons, steel that would have been used for other purposes, but was instead welded to vehicles where it stopped bullets and saved soldiers. The exact casualty reduction attributable to armored Jeeps cannot be calculated because controlled comparisons weren't conducted, but field commanders consistently reported reduced crew casualties in units operating armored Jeeps compared to unarmored vehicles in similar tactical roles. The engineering was crude by design standards but effective by tactical measures. Quarter-inch steel plates attached with basic welding provided sufficient protection against the most common threat, rifle fire from ambush positions, while remaining within the Jeep's approximate payload capacity. The solution wasn't elegant, but it worked well enough that thousands of crews trusted their survival to steel plates that regulations said shouldn't exist. The soldier who first welded armor to a Jeep and ignored orders to remove it demonstrated initiative that tactical necessity justified, but regulations prohibited. The soldiers who copied the modification across thousands of Jeeps demonstrated distributed innovation that formal institutions struggled to suppress. And the general who authorized the practice after observing its effectiveness demonstrated institutional learning that pragmatically accommodated rather than dogmatically resisted battlefield innovation. The death ray never worked because physics imposed insurmountable limitations. The armor-piercing shell worked through 50 years of metallurgical refinement. The improvised Jeep armor worked because soldiers recognized a problem, experimented with solutions using available materials, and proved through operational use that a quarter-inch steel plate positioned at critical locations provided protection that saved lives, even though regulations said the modifications were unauthorized. 79 years after Robertson crouched behind steel plates that shouldn't exist on a Jeep, the vehicle that represented his innovation, assuming he existed as an individual rather than a composite, is gone, scrapped decades ago or rusting in a field somewhere. The armor plates were cut off after the war ended because peacetime policy mandated returning vehicles to standard configuration. The modifications that saved hundreds of lives were erased because institutional memory valued standardization over preservation of tactical innovations. The lesson survived even as the physical evidence disappeared. Soldiers innovate when tactical necessity demands and institutional policy lags. The innovations that succeed spread through informal networks faster than formal approval processes can respond. And institutions that eventually accommodate rather than suppress battlefield innovation perform better than institutions that enforce regulations regardless of tactical relevance. The improvised armor on World War II Jeeps represented soldier initiative, translating available materials into tactical advantage using basic metalworking skills and willingness to violate regulations when survival demanded. The work wasn't sophisticated, it was welding steel plates to vehicles, but it solved a real problem that formal institutions hadn't addressed. And the solution, crude and unauthorized as it was, worked better than regulations that prioritized vehicle standardization over crew survivability. The Jeep with welded armor plates that Robertson operated in Normandy exemplified military adaptation at its most fundamental. Take standard equipment, recognize its limitations under combat conditions, modify it using available materials to address the identified deficiency, test the modification under operational conditions, refine based on results, repeat until the solution works adequately or circumstances change. Ignore regulations that prohibit the modification because survival matters more than procedural compliance. This wasn't heroism in the conventional sense, it was practical problem-solving that soldiers executed thousands of times during the war across every theater and every branch. The improvised armor on Jeeps was one example among hundreds of field modifications that improved equipment performance or crew survivability despite official disapproval. The innovations weren't documented systematically because they didn't fit institutional processes that tracked manufactured equipment through formal channels. But the results were documented through casualty reports that showed armored Jeeps suffered fewer crew losses than unarmored vehicles. And when enough field commanders reported the same pattern, institutions eventually changed policy to authorize what soldiers were already doing. The authorization came too late to credit the soldiers who innovated first, but it came soon enough that thousands of Jeeps received armor that protected crews during the war's final campaigns. The sergeant who started it all, whether Robertson or someone else whose name was never recorded, demonstrated that initiative matters more than authorization when lives are at risk. And the general who eventually authorized improvised armor demonstrated that institutions can learn from soldiers faster than soldiers can learn from institutions when tactical reality forces institutional adaptation. The improvised armor turned Jeeps into something they weren't designed to be, fighting vehicles capable of surviving contact rather than transport vehicles expected to withdraw. The transformation saved lives measured in hundreds, possibly thousands, through modifications that cost institutional flexibility but provided tactical advantage where it mattered most, in combat, where bullets killed unprotected crews but bounced off steel that regulations said shouldn't be there. The Invincible machine wasn't invincible. It just survived ambushes often enough that crews trusted it more than unarmored vehicles that followed regulations perfectly but offered no protection when machine guns opened fire from hedgerows at ranges too close to escape.